All right, so with our notes, guys, let's just, I've written some stuff there, and I think it'd be good to start with by having a read of what it means. So I'm going to sketch our first function so that I can talk about it as well with it. So if we just go into our graph mode, and graph, and we're going to sketch, our first function is x squared take 4x plus 2.
We pretty much should be gradients like what we did.
Yes. And just with the standard V window, and we should all have the same. Okay, so it's a quadratic function, and I might even sketch it here just so that I can point to it and so forth. All right. So we have a function is increasing if as x increases, y increases. So if we look at this function here, it's increasing from this point onwards. All right, as x increases, y increases. So that's what we call increasing. Always think about it as walking up a hill. If you're walking up the hill as you walk along the function, it's increasing. If you're walking down the hill as you walk along the function, it's decreasing. We always walk from left to right, just how we read a book. All right, so we can see this function is increasing there and it's decreasing there. To find when a function is increasing, we draw the sign diagram of f dash of x. Okay, recall, f dash of x is the slope function. The sign diagram of f dash of x tells us when the slope is positive and when the slope is negative, and hence corresponds when f of x is increasing and decreasing. All right, so can I make that link? If this is our function, the derivative function will be 2x take away 4. Very good. This is the equation of a line. All right, if we differentiate a quadratic, we end up with the equation of a line. Now, what we're going to do is we'll sketch the graph of this line and its sign diagram. If we want to sketch the graph of the equation of a line, we have a y-intercept of -4. I think the best way to sketch a line is go, well, the y-intercept is -4, and the x-intercept occurs when the y value is 0.
Y-intercept
Of the line here. Yep, that's correct. The y-intercept of the line is -4. Not the quadratic. The line. Yep. So the y-intercept of this line is -4, and the x-intercept occurs when the y value is 0. So it's when 2x take 4 equals 0. 2x is 4, x is 2. So the best way to sketch a line is to go, okay, x-intercept, the y-intercept -4, the x-intercept is +2, so we have a line going through that. All right, now if we're to sketch a sign diagram of this function, what a sign diagram is it's an axis, it's an x-axis that indicates when a function is above and when it's below the x-axis. So here we have the roots and asymptotes on the sign diagram. We learned sign diagrams in year 11, and you recapped them at the end of last year when you were in calculus. Now what we can see is to the left of 2, it's below, and to the right of 2, it is above. Okay? This is the sign diagram of f dash of x. Now what I want to point out is a link between this sign diagram and the OG function, the original function that we've sketched, right? This sign diagram, what it tells us, remember it's the slope, it tells us we have negative slope until we get to x is 2. What does negative slope mean? Negative slope means you're decreasing. All right? If you have negative slope, it means you're walking down the hill. We have negative slope until we get to x is 2, and then we have positive slope after x is 2. If we look at our graph here, if we g-solve that point at that minimum point, all right, I've got x is 2. We can see we're decreasing until we get to x is 2, and then we're increasing after that. So what we're doing in this exercise is we're using calculus techniques. So we're finding the derivative function, drawing the derivative function's sign diagram, and we use this sign diagram to make statements about the original function. the statement we're going to make about this original function is, let's erase it, increasing when x is larger than 2, decreasing when x is less than 2. Alright, now my assumption is we're comfortable with those domain rules, those statements. Here we have values of x larger than 2, values of x less than 2. If it's a skill you want to develop, I've got a really good way of developing it slowly. So let me know if you're not sure how I come up with those, but we're just reading it straight off there. Okay, let's move on to B. So our process is find the derivative, draw its sign diagram, and then answer when is it increasing, when is it decreasing. So in order to differentiate this function, we're going to need to use the quotient rule because we have one function divided by another. We have u divided by v. So we'll go u is going to be x squared take 5x take 36. U dash will be 2x take away 5. V is x plus 2 and v dash will be 1. Smash all of that together. All on top of v squared. Okay, that's our derivative function. Now what we're going to do is we're going to solve this sign diagram. We can solve it manually, alright, and we can solve it manually by expanding and collecting the like terms up the top here. So we'll go ahead and do that. I'm going to expand this. This is going to be FOIL. We'll have 2x squared, we'll have plus 4x, take 5x, take 10. And then we're taking away this quadratic here. All on top of x plus 2 squared. And now we'll just collect the like terms the whole way along. Have 2 lots of x squared, take x squared. That gives me 1 lot of x squared. We have 4x, take 5x, that's minus x, and then it's going to be plus 5x is positive 4x. And we have minus 10 plus 36 gives us positive 26. That's our derivative function. Okay, now from here we can find the roots. All right, the roots are going to occur when the numerator is 0. The asymptote occurs when the denominator is 0. So we should be looking at that and going, well, I'm going to have an asymptote at x is minus 2. And in order to find the roots here, we could try and factorize it, or we can use quadratic formula, or we can use our calculator. So we know there's an asymptote at minus 2. Just in our calculator, I'll show you a few strategies for solving polynomials. So, revealing 2 calculator skills here. We go to the main menu, and we go to equation solver. We should be familiar with this one. This is a polynomial. All right, a quadratic, a quartic, a cubic, they're all types of polynomials. The degree is 2. And then all we do is we enter the coefficients of A. A is 1, B is 4, C is 26. So 1, 4, and 26. Press solve. No real roots. Okay, interesting, no real roots. This is a good opportunity for us to recap that. Now, if one way we could find these roots would be using quadratic formula, right? So just to recap quadratic formula, we have minus b plus or minus b squared take 4ac, all divided by 2a. So if we put that into our into the formula here, we have b is 4, we'll have 4 squared take 4, a is 1, and c is 26. And I'm going to show you why we're arriving at that error over 2 times 1. Alright, so hopefully we're all comfortable subbing into quadratic formula. So minus 4 plus or minus the square root of, we'll have 16, take, now 4 times 26, 4 times 25 is 100, so 4 times 26 will be 104, divided by 2, and that's going to be 16, take 104 will be negative 88. So why are we getting an error?
It's a negative square root.
Excellent, everyone can see that. We have a negative square root here. And so this reveals another skill that's important from Year 12 methods that we covered in Year 11, is the discriminant, the triangle, delta. Delta is b squared take 4ac. It's this inside of the brackets of the root there. Now, the rule is if delta is positive, a quadratic has 2 roots. If delta is 0, a quadratic has 1 root. And if delta is less than 0, a quadratic has no roots. Alright, so that's something we've learned in Year 11, but I'm providing a recap of here because it will pop up throughout the course. So we can see, we tried to type into a cat that said no solution. Let's demonstrate why. Here's why there's no solution. Alright, it's because the discriminant is this inside part and the discriminant is negative. If the discriminant is negative, there are no roots. There's no roots to this quadratic, which means the only thing that goes on our sign diagram is the asymptote. Now, if there's no roots, what this means is this function doesn't cross the x-axis. All right, because what are roots? Roots, x-intercepts, solutions, zeros, that all means the same thing. That's when it crosses the x-axis. Okay, show you another trick how we can use our calculator. So you might be thinking, all right, well, let's get the sign diagram from our calculator. Our calculator is our friend. Now, what I'm going to do is I'm going to sketch the original function and I'm going to sketch the derivative function. I'm going to write both of them in. So our first function is, we have x squared, x squared take 5x take 36 on top of, on top of x plus 2. So that's the first function. Alright, now you can type the derivative function in as well, which is x squared plus 4x plus 26. Alright, and I'm going to show you here is a way of checking if we've done some correct working as well on top of x plus 2 squared. Okay, now we'll keep the V window as standard, but what we're going to do is let's just graph both of those over the standard V window now so we can have a look at both of them. Okay, so the blue function is the original one, the red function is the derivative, and already we can see that asymptote at x is minus 2, and we can see it's above and above. Okay, if I'm just looking at the red function, it's above and it's above. That's what its sign diagram looks like. So, what this means, like if we're answering the question using our calculator to help us, we're increasing for x is less than minus 2, and we're increasing for x is greater than minus 2. Can anyone tell me, why am I not including the point this time? That's right, it doesn't exist at the asymptote. Over here, in our first example, we did include the point because it exists at that point. Here, we don't include the point because there's an asymptote there. So it's a way of us demonstrating whether there's an asymptote occurring in a single statement. All right, so it's increasing for values less than minus 2. We have positive slope, and increasing for values larger than 2. And we can see that from the graph as what the original graph, all right, if I just turn off the derivative for one moment. So we just look at the blue function. You can see as we walk along it, it's increasing, and then we jump over the asymptote, and as we walk along it, it's increasing. So we have positive slope on both sides. So this is the sign diagram of f dash of x. This tells us about the original function. Okay, here's the new skill I want to reveal to you though. What we're going to do is in y3, let's turn off the original function by the way, and what you can do is, do you see how the blue function is, the equal sign is highlighted, whereas in the red function it's not? What that means is it's going to graph the blue function, it's not going to graph the red function. And the way we do that is we just select a function and that turns it off or on. So at the moment, it's not going to graph the blue function, it's not going to graph the red function. I'm going to turn the red function on, and I'm going to graph another function as well. And this is our checkpoint. What we're going to do is we're going to go Option, Calc, D on DX. All right, so we learned to do this in Run Map. But what we can graph is the derivative of y1. Okay, y1 because y1 is the original function. Now what we expect is these two functions, the red function and the green function, if we're correct in our working, we expect them to be the same function. That's because we found the derivative manually here, that's the derivative function, and that's what we've got sketched for y2. And now for y3, what are we doing? We're using the calculator to sketch the derivative function. So we just press evaluate. Gorgeous, did you see that? It was red and then it turned to green. They are the same function. They both have that asymptote at x is -2, and they're both positive either side of it. Okay, so I've gone over a lot with that question. In particular, we talked about the discriminant and the quadratic formula. We talked about this quadratic having no roots, so there's no x-intercepts, there's only a asymptote. All right, so let's look at C. C will be a bit faster. C, we have the function y equals e to the x. So our process is this. Differentiate the function. Draw the sign diagram of the derivative function.
It's 2 rows, isn't it? F dash of x. Not the
Oh, sorry. It's y, is it? F of x and f dash. Thank you. F of x and f dash. Okay. We're going to sketch the sign diagram of the derivative function. Now, e to the x is a exponential function. It has no roots, which means you'll often see me write this. E to the x never equals 0. If you look at the graph of e to the x, this is what it looks like. It's asymptotic to the x-axis, and we learned that in chapter 1. That's something to remember. E to the x will never equal 0, which means it's completely above. Okay, so again, we're using the sign diagram to make statements about the original function. What do we know about the original function? If there's no roots, there's no asymptotes, it's got positive slope, always it's increasing for all values of x. And so we would write increasing x, e, r. All right, those are the values for which it's increasing. And we can see that anyway from the graph of e to the x. Okay, if this is the graph of e to the x, as you walk along from left to right, you are always increasing. So what we're doing is you can look at the original graph and you can observe where it's increasing and decreasing. But what we really want to do is use these calculus techniques. What's the process? Differentiate, draw the sign diagram of the derivative, and then you use the derivative to make statements about the original function. Okay, use your calculator to help you out to get those sign diagrams. But yeah, that's how we're going to do 3B. Let's get into it.